Good morning to all. So in this video lecture, I am going to discuss about the topic Introduction to AC circuit. In today's scenario, so most of the commercial and industrial applications they are depends on alternating current source only. So the three major main components of AC circuit, that is resistor, capacitor and inductor. So resistor is nothing but which restricts the flow of current. Capacitor is nothing but which stores energy in the form of electrostatic DC energy storage element, and inductor, it is also stores energy in the form of electromagnetic, it is also a energy storage element. So all the three elements having one common property, that is which restrict the flow of electric current. Then the voltage and currents are marked by direction and magnitude in an AC circuit. The alternating values may or may not be in phase with each other, relying on the different variables of the system like capacitance, inductance and resistance. So in an alternating circuit, we are having the voltage and current, so both having the waveform. So voltage and current, there is a relation between phasor. So if suppose the circuit having only resistance is present, so that circuit voltage and current relationship is there is no phase displacement between them. So the circuit will be worked under unity power factor condition. If suppose the circuit having purely inductance presented only, so that circuit having voltage and current relationship, voltage is lagging the current by some phi angle. Similarly, for the capacitance circuit, the voltage is leading the current by some phi angle. So for the inductive circuit is working under the condition of lagging power factor, for the capacitance circuit working under the condition of leading power factor. So this is your sinusoidal nature of alternating current. It has 0 to 2 pi time period. The magnitude is either EM or IM, it depends upon which type of waveform is presented here. The main thing is the alternating current is an electrical current that regularly reverses direction and it changes its value constantly with the time. So it changes its value constantly with the time means it has a positive value and negative value, but the magnitude should be same. So some basic parameters we are identifying about this sinusoidal waveform, that is first thing is amplitude. So amplitude is nothing but the maximum positive or negative value attained by an alternating quantity in one complete cycle is called amplitude or peak value or maximum value. Then alternation. So alternation is nothing but one half cycle is termed as alternation, and alternation span is about 180 electrical degree. Cycle, so cycle is nothing but when one set of positive cycle or negative values completes by an alternating quantity or it goes through 360 electrical degree is said to have one complete cycle. Then instantaneous value. So at any instantaneous of your voltage waveform or current waveform, you can get the value. So that is called the instantaneous value. So all the instantaneous value combined to get the waveform. Then frequency. So frequency is nothing but number of cycles made per second by an alternating quantity is called frequency. It is measured in cycle per seconds or hertz and it is denoted by F. Then time period. So time taken to complete one cycle is called time period. It is denoted by capital T. Then finally waveform. So waveform, it is collecting the data from instantaneous value and make a waveform. So normally for a voltage waveform, the sinusoidal waveform, so the corresponding mathematical expression V is equal to Vm sin omega t. For the current waveform, I is equal to Im sin omega t, where Vm and Im are the constant value of your waveform. The corresponding sin omega t and sin omega t represent the instantaneous values of your waveform. So this will be that collection of instantaneous value will form a waveform. So thank you for your listening.